Oh yes, again I welcome you all for another lecture, another class on static force analysis. I have mentioned the terms, what all things I wish to discuss in today's lecture. Okay, as you can see here, so force, okay, then I have drawn a line, then few points, 2-force system, 3-force system, 4-force system, two force and a torque or moment system. Then what do you mean by force body, free body diagram? Okay, all these points I wish to discuss. Okay, so what is there to discuss force? Force, probably that term has been introduced you to probably during your 8th class or so. So according to Newton's first law, force is defined as something which tends to change the state of the body. Then Newton's second law measures the force, F is equal to ma, etc. All those things you know it. Okay, so I don't want to go in detail on the discussion of all that. So I need to discuss force here. So force, to describe force, I require a couple of things. What are the things? As we know that force is a vector, force, to describe it we need magnitude. So usually 10 kilonewton, 5 kilonewton, 100 newton, something like this is the unit, and magnitude. So Newton is the unit of force. So you require magnitude? Yes, fine. So it is a vector quantity, we require what is called as the direction. So any vector quantity is represented by drawing a line along with your all that, you know it. Okay. So suppose I have 100 kilonewton force horizontally. Okay, horizontally, if I mention only that, say 100 kilonewton force horizontally, then it may be this force, I don't know, horizontally towards right or horizontally towards left, that I have not mentioned. Say horizontally towards right, 100 kilonewton horizontally towards right. So maybe this, or it may be this force also, or maybe I can draw another one, okay. So apart from these two, the magnitude and direction, you also require another thing. What is that? Point through which the force passes through. Okay, we also require, suppose I say 100 kilonewton horizontal force passing through a point X. That means this is the force. Okay, it is not this force. So therefore, so you require the magnitude, direction, and the point through which the force passes through. So you may ask me, so whether this 100 kilonewton, whatever I have drawn here, whether it passes through only X? No, it doesn't pass through only X. You choose any point on this line and on this side also. All these points through which the force passes through. Okay, so if I don't mention that, then this line, what is this line is called as? This line is called as line of action. The line of action. Suppose many times we don't know the direction, but the points, I'm not mentioning points. If you know 2 points through which the force passes through, join those 2 points and extend on either side, what do you get? You get the line of action of the force. So many times in our discussion, that also is going to be very useful. The magnitude, then line of action, or sometimes direction also. Okay, many times we are happy with line of action of the force. Even if I don't know the direction, it is all right. Okay, the line of action, if you know, then you choose any point on that line of action. That is a point through which force passes through. So this is what I wanted to tell you about the force. So magnitude, line of action, point through which the force passes through, or points through which the force passes through, or what is the direction. So these are the different things we deal with force in our analysis. Okay, so then the next one. So as I said, I want to talk about the equilibrium conditions. Again, as I said, here the title of the topic itself is static force analysis. So therefore, none of the link of the mechanism is going to move. They are going to remain stationary. Therefore, the whole mechanism remains in a equilibrium condition. Okay, so that is what I am going to apply. So in my analysis, so I am going to have links say a link which is subjected to only two forces, or I may have a link which is subjected to only three forces, or I may have a situation wherein a link is subjected to two forces and also one moment or one torque, one couple, like that. So that's what I mean by this. So though in your syllabus probably this 4-force system is not mentioned, but I have included it. On what grounds we are going to discuss, deal these things. That is why I have included 4-force system also. Okay. So therefore now what is the meaning of this system? System is nothing but a link in our case. System is nothing but only one link. Okay. So 2-force system. What is the meaning of that? One link subjected to two forces and remains in a equilibrium state. That is the meaning. Similarly, what is meant by 3-force system? That is a link. There is a link which is subjected to three forces, and that system, that link remains in a equilibrium state, like that. So therefore, you don't have to get confused or think too much about system. System is nothing but link in our analysis for this purpose. Okay. So now, let me go by. So now, though the equilibrium conditions remain same, what is that? So for planar forces, as I said, our discussion is going to be entirely limited to planar forces. Therefore, my discussion also is going to be limited to planar forces. What are the equilibrium conditions which I mentioned in my previous class? The same thing. One is the resultant force equal to 0, and number 2, the moment due to all the forces about any point is equal to 0. So that is what I am going to apply for all these situations, and then arrive at a useful conclusion which I am going to apply when I start solving problem. Okay. So now a kind of preparatory work for our takeoff. So finally in the examination you will be given one mechanism and analyze, say one force or some forces are applied on some links, and then you are asked to find out something. This is what is the kind of problem, and normally it is usually treated as full marks. If it is a 20 marks question, maybe about 14 or 15 marks are for that problem and 4 or 6 marks for this kind. I think this question also is very common. What is that? State the equilibrium conditions for this case, this one, like that. We are going to apply equilibrium conditions for all this and then arrive at a useful conclusion, and that conclusion we are going to apply when we start solving a static force analysis of a mechanism. This is what we are going to do it. Okay, now let me take this. Let me start with this. What is this? 2-force system. What do you mean by that? There is one link or one body, and that body is subjected to two forces. Okay, so out of the two forces, so let me take, say this is a link. Okay, this is a link. It may be like this or it may be a body like this. Both of them will do. Okay, so now this is subjected to say two forces. Say let me take this case and say I have one force, what is called as say F1. So F1, what are things I know? I know magnitude, and I also know direction. I also know line of action. Or in other words, I also know the point through which the force passes through. All the things. That means the force, this F1 is known completely. Nothing is unknown. Magnitude is known, direction is known, line of action is known, everything is known. Therefore, this force is known completely. Now I have one more force I am going to apply on this F2. I don't know its magnitude or I don't know its direction. But I want to find out so that this body remains in equilibrium state. That is my idea. Okay. So now apply. So what is the first condition? The resultant force must be equal to 0. So this force is already there. There must be one more force, and that force must be opposite to this, and it must have the same magnitude. And the first observation what we conclude is F2 is also equal in magnitude to F1, and it is exactly opposite to F1. That is what. Okay, so it is opposite and equal. Okay, but can it be anywhere here? Can I say F2 is somewhere here? So it is opposite and it is having the same magnitude. Fine. Then the first part is alright according to the resultant condition, that is okay. But I have one more condition of equilibrium. What does it say? The moment due to all the forces about any point must be equal to 0. If this is a force, then this force is extended. This force, you know that they are parallel to each other. There is a perpendicular distance between the two. The two will form a couple and that will start rotating the body and therefore it will not remain in a equilibrium state. Therefore, F2 cannot be anywhere. It has to be exactly along the same line. So this is what must be F2. F2 must be equal to, F2 is equal to minus F1. And not only that, and they have to be collinear. So what is that? What is the observation general conclusion now? The two forces must be equal in magnitude. They are opposite in direction. And they have to be collinear. The line of action of one force coincides with the line of action of another force. This is what is the meaning of this. The two forces must be equal. After my lecture, please write it down. Two force system. Write it in somewhere in the corner of your paper and in your brain. Whenever two force system. Two forces must be equal, opposite and collinear for the equilibrium of that system. That is what is the meaning, and this is what I want you to write it down here very importantly, and every now and then we are going to apply it, and that is how we are going to solve the problem. Okay, I hope it is clear. Two force system. The two force system, it will remain in the equilibrium state if the two forces are equal, opposite and collinear. Now let me move on to what is called as three-force system. Three-force system. Okay, what is three-force system? I have a link or I have a body which is subjected to three forces. So again what I do is, out of three forces, I shall assume that I know two of them. And I want to find out the third one, and in doing that I shall assume or I shall arrive at a conclusion. Okay, please remember, it may be a body of any shape, doesn't matter. It may be a link which is normally shown something like a line, in that case also. So now I am having a body which is subjected to three forces, and out of that three I know already two forces. Let me assume that F1. What do I know? I know the magnitude, I know the direction, I know the line of action. Similarly, another force F2. I know the magnitude, I know the direction, and I also know the line of action. Okay, we have something what is called as resultant. What is resultant? Resultant is a single force which replaces a number of forces. In this case, I want the resultant to replace two forces, F1 and F2. How you can find it out? If you have only two, then you can use the law of parallelogram of forces, or you can add them vectorially and find out what is the resultant. Okay, so I know that if I do that, so I don't want to find out the exact magnitude of the resultant, but I want to know where it is going to act. The resultant, where is it? What is the point through which the resultant will pass through? Okay, so that can be easily found out by getting the intersection of the line of action of the two forces. I extend this line of action, and I also extend this line of action. So this is the point through which the resultant of these two forces will act. However it may be. So what you can do, probably you take F2, you can take F1, probably you can, depending upon the magnitude, you can choose the scale here, and then construct the parallelogram, then draw the diagram. You can easily find out the resultant. That is fine. But that resultant will pass through this point. Okay, if I call it as resultant, then that force I shall call it as F12. Let F12 be the resultant of it. Okay, the resultant of F1 and F2 I find out, and I call it as Okay, if you are not happy, then I shall make it as R12. Let R12 be the resultant of the two forces F1 and F2. I know that it is going to pass through this point. It is going to pass through this point, and it may be in any direction depending upon these magnitudes, line of action. Now I have a third force. Now it is as good as F1 and F2 are replaced. Now it is R12. R12 is a single force, and I have one more force which is going to act on this, that is F3. So now it is a case of 3-force system has been reduced to 2-force system. So which are the two forces now? What was the earlier starting problem? The body is subjected to 3 forces, F1, F2, F3. Okay, now F1 and F2 have been replaced by one single force by the resultant, that is R12. Now how many forces are there? One is R12, and what is the other one? What is the other one? The other one is F3. Now it is subjected to R12 and F3. It has become now 2-force system. What is the condition of equilibrium? The two forces must be equal, opposite and collinear. So therefore, whatever may be the line of action, if R12 is like this, if R12 is like this, then F3 also must have the same thing, no? So therefore, F3 will also start from this point, and it is exactly equal and opposite to the resultant. So one common thing, what do I have for the equilibrium of this 3-force system? I can say that 3 forces F1, F2, F3 must have, what is this point? This is common point of F1. This is the point through which F2 also will pass through. This is the point through which F3 also must pass through. So therefore, for 3-force system, very important thing what I need to write. For the equilibrium of 3-force system, one of the condition is all 3 forces must have a common point. One point through which all 3 forces have to pass through. But that is not sufficient. All 3 forces must have a common point, and the resultant of all the 3 forces must be equal to 0. Okay? Or in other words, F3 is exactly equal, opposite and collinear to R12, I can say. So in that case, R12 is equal to F3, they are opposite, and what is that? It is equilibrium, the resultant is 0, and therefore, what is the condition here? 3-force system. The 3 forces are equal, opposite, the 3 forces are having a common point through which all the 3 forces pass through, and the resultant of all the 3 is equal to 0. That is the condition. So now, if I go for 4-force system, the same thing what I do. Okay, what do I do is, I find out the resultant of 2 forces. This 4-force system, I replace it by 3-force system. How? So you know 2 forces. 2 forces you can replace by the resultant. You can get the common point of the 2 forces, and that is the point through which the resultant of those 2 will pass through. Then how many are there? One is resultant, then the other 2. The other 2, this is reduced to 3-force system. What I want to tell by introducing is this. So if you have 4-force system, try to make it 3-force system. If you have 3-force system, make it to 2-force system. That is how you apply the conditions and get carry on the analysis. I shall not take this. This is not mentioned in your syllabus, but later on, if required, I shall go through the question paper. If there is any such problem, I shall solve it. Okay, then I shall come to what is called as, what is this? 2 force and 1 moment. 1 moment, 1 torque, whatever. Okay, the body is subjected to 2 forces. Okay, then, so I shall, out of these 2 forces and 1 moment, so now I shall assume any 2 known things. I can assume 2 forces as known and 1 moment is unknown. That is one way. Or I can assume 1 force and 1 moment and another force is unknown. These are the different possibilities. So let me start with the first case. So what is that? two forces are known and one moment is unknown. Okay, two forces are known. Two forces are known and one moment is unknown. Okay, please remember, it is not subjected to only two forces and remains in equilibrium state. In that case, it would have been the first case. It is not that. I also have a moment. I have two forces and also have a moment. Then only it will remain in equilibrium state. So, do you agree that? Do you agree that the two forces are not collinear? If you have two forces collinear, then there is no question of forming moment. There is no question of forming moment, and therefore, the two forces are not collinear. That is the first thing. So let me assume that this is F1. Okay, the two forces are not collinear. Okay, then are they parallel or are they not parallel or anything like this? If you have anything like this, say suppose one force is like this and then force is like this. So now I can immediately say that the resultant of F1 and F2 is never 0. The resultant of F1 and F2 is never 0 if they are like this, and therefore they can never be like this. They are not collinear and they have to be parallel. They have to be parallel for becoming the resultant equal to 0, and they also have to be opposite. Okay, remember the first condition of the equilibrium, the resultant force must be equal to 0. So one force is known, then the second force must be opposite to it, and they are not collinear. That's what we have already observed. So therefore, the first force F1 and the second force F2, they are exactly opposite to each other, and therefore the resultant is 0. Okay, so then I have what is called as, suppose x is the distance between the two forces F1 and F2. This F1 and F2, they together will form a moment that is equal to, please remember the first condition is F2 is equal to minus F1. That means the two forces are equal, opposite and parallel to each other. The couple formed by these forces, what is the couple now? F1 multiplied by x. F1 multiplied by x is the couple that is formed by these two forces, and that is right now in this case is in anti-clockwise direction. That must be balanced because I don't want this to start rotating, and therefore I apply a moment what is called as m0. Why in this direction? Because the couple formed by this must be balanced exactly opposite to this. So therefore, what is m0? The m0 is equal to f1 into x. Okay. Now it is in equilibrium. F1 is exactly equal and opposite, and therefore the F1 resultant force is 0. This F1 and F2 they form a couple, F1 multiplied by x, which is in the anti-clockwise direction, and that is being balanced. I have applied a moment m0 which is also equal to F1 into x in the opposite direction, and this will remain in equilibrium state, and therefore, so what is the condition now? So if I write this kind of conclusion, so what is that? The two forces must be equal, they have to be opposite, they have to be parallel. The two forces are equal, opposite, parallel, and the couple formed by these two forces is exactly equal and opposite to the moment applied. The moment whatever you have applied now, that moment, and the couple formed by these two forces, they are exactly equal and opposite. So even if you take the other case also, you come to finally the same conclusion. What is that? The two forces must be equal, opposite, parallel, and the couple formed by the two forces must be exactly equal and opposite to the external moment. I hope you understood. Okay, so that is the meaning of this. Please write down. I have left it blank. Please listen to my lecture and then write down this on your own. This is what I am going to use it for solving a major question. What we saw, what we discussed, as if almost one full question of a question paper. Okay, so 4-bar mechanism, slider current mechanism, or any other mechanism like quick return motion mechanism, that I am going to take and pick this and apply, and that's what is the answer I am going to find out. Okay, the last point what is called as free body diagram. Okay, so those who have attended my lectures anytime, so I don't think you can miss this word free body diagram. Free body diagram in mechanics of materials also we use, and in many subjects also we use it. What is free body diagram? It is basically isolating. Isolating what? Isolating maybe part of the body. So this is what we do it in the mechanics of materials. Isolating maybe part of the body, or maybe one full body, or one full link in our case, or sometimes a couple of bodies or couple of links, a few bodies together, maybe more than one body also I may take, say 2 bodies, 3 bodies, like that. Okay, so I repeat, start. What? Isolating. Isolating what? Maybe a part of the body, or one full body, or a number of bodies. Isolate from what? Isolate from its neighbors. Okay, if you isolate from your friends, I hope you understand. Similarly, isolate, say, part of the body or one full body or a number of bodies from its neighbors, and draw them and show all the forces that are acting on it. That is what we call it as free body diagram. Very simple. Free body diagram is obtained by isolating whatever is required and showing all the forces acting on it. And that is what we call it as a system. When you do it, sometimes it turns out to be 2-4 system, sometimes it turns out to be 3-4 system or 4-4 system or this, and this is what the conclusion, whatever we have drawn here, that we are going to apply and find out the answer. Okay, so I have made all the preparations now ready for takeoff. You should be ready. So when we meet next time, so I want you to come fully prepared. So I want you to carry your drawing instruments, at least scale, eraser, then compass, and I also request you protractor, maybe those 2 set squares. So that also is going to be useful. I wish you to be ready, and we shall solve a problem which will be very useful for your IIT test also. Yes, good day.